Thank you very much, everybody. It's nice to see so many of you here tonight. And so I will talk about R for data science and the packages called Tidyverse. And my name is Olof Rännbäck, Garpinger. First, I'll give you a short introduction to who I am. I was born and raised in a small village just outside Hässleholm in the north of Skåne, and came down to Lund in 1999 to start studying engineering physics at Lund University. I then specialized within automatic control and pursued with a PhD in the same topic also at Lund University. I did my research on optimal PID controllers for factories or process industry, such as this one, like, for example, chemical plants or pulp and paper plants. I've also a number of years of experience as a consultant for Svensk Kärnbränslehantering AB, so SKB, which is a Swedish company that takes care of the Swedish nuclear waste. And I was involved in a project that will in the future seal copper canisters holding the Swedish nuclear waste. And this is the friction stir welding machine that is a prototype of the machine that in the future will seal together the copper canisters. I worked on the temperature and depth control of these welds, and I also analyzed a lot of data from more than 300 welds, and each weld holds quite a bit of data. There I mainly used MATLAB because from my education in automatic control is really used. It's really common to use MATLAB. But then in 2016 or late 2015, I met an old colleague of mine who has just begun his job at King as a data scientist here in Malmö. He told me about data science and I got really interested in it, started taking courses, and it's been a really enjoyable journey since then. And there I got into R programming, and all of my studies or some of my studies I've been able also to apply on the SKB project. So today's ingredients are the following. First of all, why do we need data science? And what is it? Next, something about R programming, so a small introduction to R programming and the Tidyverse. Third, I will present some data that I will use to show the benefits of the Tidyverse. And four, I will go through a number of the Tidyverse packages, the key functions that I see in these. And I will also talk about pipelining in the Tidyverse. So why do we need data science at all then? Well, if you have a company or you have an organization that generates a lot of data, then it's easy to get overwhelmed by the sheer amount of data. We are generating more and more data for every day that goes on. And then we are talking about how you drown in data but starve for knowledge. Because it's so much data that you don't know what to do with it. Then data science is about getting in control. Get up on our surfboards and surf through this flood of data, discovering business knowledge and opportunities in the data. For a hot topic such as data science, there are several definitions of data science, and I will give you mine. First of all, I would say that there are mainly three different areas that's good to know if you're going to do data science. First of all, mathematics and statistics to draw the correct conclusions from your data. Programming, because the data will come in electronically into your computer and you will analyze it using a program like R, Python, and if it's really massive data amounts, then you perhaps need to use a cluster of computers, and then perhaps you need tools like Hadoop and Spark. Third, but not least, is business experience, because without it, knowledge about what you're working on, then you don't know how to ask the correct questions about the data. And it also helps you a lot in drawing the right conclusions in the end. So together becomes data science. And the group of people working with data science are often called the data scientists. And one possible way of doing the work or workflow as a data scientist, perhaps hard to see here, but first importing data, for example, from a database or from an API or a file. Then tidy it up, because often the data comes in a format that's not so suitable for the rest of the parts here. Then before we go into this loop, we ask questions about the data, typically, that we want to find out. And once we did that, then perhaps you want to transform the data, introduce some new variables, so-called feature engineering. We want to explore it using visualizations, plots, and modeling, machine learning. And then we get new conclusions, answers to the questions, ask new ones, and then we go on and on until we get a number of conclusions that we want to communicate to the company that we are working on. So I would say that there are mainly two different languages that data scientists use to analyze data, and it's R and Python. And since R is the language that I've been working with mainly of these, it will be what I will talk about today. So R is the language and environment for statistical computing and graphics, which has been around for roughly 20 years. It is completely free and can be downloaded from CRAN. It is most often used together with the IDE called RStudio. And that one can be downloaded from rstudio.com. There are a large number of packages available with R for statistics, machine learning, visualization, data manipulation, and so on. And this is one of the big reasons why it's gotten so popular among data scientists. And it's also much thanks to the Tidyverse. So the Tidyverse is a collection of R packages for doing data science. And they share a common philosophy on data and R programming. You can say that they are a modern take of original functions in R for doing reading of rectangular data, data frames, visualizations, manipulation of data, data tidying, iteration modeling, and so on. And the packages that I will talk about today are the ones in green. All of these packages and several more are very, very pedagogically written about in this book, R for Data Science, that I really recommend you to read if you want to go on with this subject. And the entire book can be read on this homepage here. It's written by Hadley Wickham and Garrett Grolemund. And Hadley Wickham has been the author, I think, of several of these packages, such as ggplot 2 and dplyr packages. And they based the book on this workflow that I showed you before, giving you tools for each of these parts. Okay, so in order to show the benefits of the Tidyverse, I will be using data from Vasaloppet. And as I guess many of you know, this is an annual ski race in Sweden from Sälen to Mora, over 90 kilometers. And roughly 15,000 skiers per year doing this one-time race. There are of course open races during the same week as well, with even more skiers over the whole week. I think it's the oldest and biggest ski race in the world, actually, but I'm not quite sure. Anyways, I got hold of Vasaloppet data. Here I will use Vasaloppet data from 2016. I got it from an old friend and a colleague of mine who used to run a website called Resultatjakt. All of the data I made available on this GitHub page, together with this presentation, by the way. It contains 13,634 rows and 11 columns, and holds only skiers that actually finished the race. However, I did slightly modify the dataset to keep the privacy of the skiers. So what I did was to remove names, remove clubs, remove the start numbers, set new IDs instead. And I also put a noise to the time, to the split times and the finish times in more. So I will try to show you the dataset. So we can see at least some of the columns in the data. So the first column is skier ID, so a unique number for each skier that I generated randomly. Then you have age class, which gives you pretty much the age of the skier. But age class 60, for example, is people that is between 60 and 64 years old. We also have a start group, so the best skiers, they are in start group number 0, and not so good ones are in start group 10, so that's the highest number of start groups. People in start group number 0, they start in the front of the race, and in start group number 10, they are in the back of the race in the start. Okay. Then we have a number of split times. You don't see all of them here. Not sure if I can scroll it. So you see from the first checkpoint in Smågan, you have the time in a second for each skier, up to Eldris, and you also have the last finish time in Mora here, also in seconds. Okay, so that was the data. To my help today, I got this guy here. Meet Bengt Bengan Karlsson. He's not a real character, he's quite fictitious actually. And I made him up to help me showing the benefits of the Tidyverse today. His age is 72 years old, and he's in pretty good shape considering his age, but sadly it's been on the decline lately. He's done quite a lot of Vasaloppet before, 35 of them, so he's quite experienced in this race. And he's also very excited this year because he will do Vasaloppet 2016 for a 36th time, and he will start in group number 5 this year, so somewhere in the middle of the start field. So over to the Tidyverse. Much like our own universe, the Tidyverse is expanding, and today I will put up small code snippets here in the slides that will show you, if you have your laptops with you, how you do what you can write in parallel with what I am showing you. So if I switch over to RStudio again, see if that works. Go into the code. And for example, I click on the line library Tidyverse. Then by clicking Control Enter, I will execute that line of code. And then it will load a number of packages. You can't quite see them here. If you want to carry along in parallel with the talk today. A fundamental corner piece of the Tidyverse are the tables or data frames. And a data frame is nothing more than a table like this one here. So think Excel, for example. In each column you have one variable, like we had, for example, the split times, the skier IDs, and so on. And in each row you have a number of observations. So in our case, it is the skiers. Okay. So we haven't yet introduced or loaded the Vasaloppet data. So instead I will use a built-in data frame called Iris in RStudio, which you can access by just typing in Iris. It describes 3 different species of iris, so flowers like this one here. And the original data frame is the original R data frame. So the easiest way to see the advantages, one of the advantages with a tibble, is to just print out iris. Then you will get all of the rows of this iris data frame. If we instead create a tibble using s.tibble of iris and print that one out, we'll get much more information, or at least a little bit more information. We'll see the data types of each of the variables. We will also see the dimensions of the data set, and also we don't clutter up our screen by printing out each row. We only print out the 10 first of them. So this is the easiest advantage to see. There are more, but I will let you explore those yourself if you want to. Okay, let's go over to how to import data sets like this one. So we want to read in our Vasaloppet dataset, and we will do that using readr. So readr is used to import rectangular datasets and files, actually. So the Vasaloppet dataset is lying in this VL 2016 mod.csv file, and the CSV file is a comma separated value file. So every variable is separated by a comma, I think. Okay, and in readr we have a function called read_csv, which produces a tibble, and it's also much faster than the read.csv from original R code. And let's say that we only use read_csv here. Then we will interpret the variables or parse them into different data types automatically based on the first 1000 rows of this variable. However, for example, look at start group. So start group was something between 0 and 10, a number. This will be interpreted as an integer, but I would rather like it to be interpreted as a ordered factor. Then I can use call types in this function to specify the this variable as a factor, an ordered factor with levels 0 to 10. And after I've run this piece of code, I can view it much like I did before using view VL 2016. Okay, so if you have written queries in SQL, or if you have done data manipulation in Python or original R, then I guess that you will be familiar with the commands or functions in the DeepLiar package. So DeepLiar is the way of doing data manipulation in the Tidyverse, and it's the smoothest way of doing data manipulation that I have seen, at least. Yeah, as far as I know, at least. So I will go through 6 key functions in the DeepLiar package. I will not go through joining of data frames. I will let you explore those yourself. So I will start instead with a select function. And with select, I select columns, of the data frame. So say that from the data frame VL 2016, I want to pick out only skier ID, age class, start group, and finish time in Mora, those variables. And I create a new data frame called VL 2016 selected. So I will go from the original data frame into this one here, where of course there's a lot more rows than you can see here. I also, if I now want to pick out observations of this data frame based on, for example, the age class, so I only want to pick out those in age class 70, then I will use filter. So I say that I will use the old data frame, filter out age class 70, and create a new data frame called VL 2016 filtered. Okay, let's go on. And this time I want to sort all of the rows after variables. So I want to sort the old data frame first after start group, then after the finish time in Mora. So this becomes this. So now we start with the lowest start group, so 3, 3, 3, 3, 4. And the Mora finish time will also increase up until the next start group. If we now want to create new variables or transform the ones that we already have, then we can use the mutate function in DeepLiar. For example, say that we want to create a new variable with the finish time in hours rather than seconds, because it's easier to interpret that. Then we create it by adding Mora is equal to Mora hours is equal to Mora through 3600. And then we add the variable with the finish time in hours, like this. So the last two functions of the DeepLiar package that I will go through are the ones to do summaries of groups. First, we have a group by, which pretty much puts all categories of the same type together. Then the next is summarize. So we take those groups and we calculate, for example, means, averages, medians, standard deviations, also over these groups. So first of all, I created this grouped data frame. I group over a start group. Then I summarize and calculate the mean of Mora hours after of every start group that I have. And I also count the number of skiers in each of these groups. So this data frame becomes this one here. For example, start group number 3 has a mean of finish time 6.8 hours, and there are only 4 skiers in that group. As you can see, or as expected, the lower start groups have better finish time than the higher ones, but there's one group that is diverging a bit, group number 5, so that's almost 9 hours. That's strange. And if you remember, in age class 70, so Bengt was 72 years old, so he's in this age class, and is also in that start group. So that's strange. Let's continue, but we'll go back to this later, this mystery. First, I want to show you the pipelining in the Tidyverse. We use the so-called pipe, which consists of these characters, and unless you want to type those into RStudio every time you do it, then we can instead use the Control-Shift-M as a quick command in RStudio. So, as you may have saw before or noticed, every DeepLiar function that we saw had a data frame as an input and a data frame as an output. So we can pipe the first data frame into select first, like we did before. So this will create the old selected data frame that we had. Then we can pipe it on to filter, arrange, mutate, group by, summarize, and so on. And by doing that, we will create the exact same data frame that we had before. And the advantage of doing this is that at least that you don't have to create intermediate names for each of these data frames. So you can do your data analysis faster. Okay. So the next part is about visualization. Returning to the flood of data. This is about painting the flood of data or doing plots. So in the Tidyverse, we use ggplot 2 to do the visualizations. And it's pretty much like with the pipe. It is a chain of commands where we first call ggplot and specify a dataset. We then use plus and add layers of geom functions or geometrical objects, such as, for example, dots, lines, box plots, and so on. And there are also several other inputs that you can use in this function, but I will not go into those today. And neither will I talk about coordinate functions. If there is time, I will talk about facet plots. I should also say that you can add several of these layers of different geometrical objects that I will show you in a minute. Okay, so first geometric object I want to show you is geom, or the geom function is geom point, and that one adds a layer of points to your plot. So what the ggplot does is only to create coordinate function, the coordinate system, and then by adding the geom point you add a layer of points. Looking at the code, I started out here with the old original data frame. I filtered out Bengt's class, so 70s, and put those in a data frame called VL 2016 AC70. Then I used this data frame in ggplot here. I add a layer of points, mapping with a static mapping. I'm putting Smågan split times as x coordinates and finish time in Mora as y coordinates. And finally, outside of the mapping, I set the size of each of these dots to 2. And to make the plot easier to interpret, I also add some labels here. This code could also be written in the following way, doing the piping from the beginning, so piping in VL 2016 into filter, and then piping it into ggplot here. So then you don't have to specify the data that I did before. And you can also set the aesthetic mapping here directly in ggplot function. Then it will hold globally for each geom in the future. So you don't have to specify x and y's for each geoms. So that will give you the same result, the same plot, both of these codes. Okay. So what you see here is, I would say, looks pretty much like some linear relationship, but yes, perhaps some diverging data points here. But other than that, I don't see that much from this data. I wonder if I can see something more if I add another dimension, add another variable. But I don't want to create a 3D plot. Rather, I want to set the color of the plots to be different for each start group. And I do that by, in geom_point, specify an aesthetic mapping that the color should be depending on the start group. And this creates the plot here. As expected, I would say, several of the higher group numbers are up here in the top right corner, so they are not very fast to Smågan and then not very fast to Mora either. In the opposite corner we have much lower groups, and also as expected, but there's something here that's diverging from what I would have expected. Can anyone of you see it? Good timing. Can any one of you see what's diverging here? Yeah. Yeah, exactly. So the green dots here seems to be diverging from the rest, and those are group number 5, Bengt's group. Yeah, and where is Bengt? It's right there, actually. If we want to make this even clearer, then we can add, for example, a smoothing function, a layer of a smoothing function layer to this plot by using geom_smooth here. And this will let you see trends in your data. So pretty much gives you a rolling mean average value over the dots. And here you can see the trends already pretty clearly, but I would say that if you have even more dots, then it might be hard to see the trends, and then the smoothing function makes more use. So the green dots, almost all of them are above this line. It's not quite linear, but looking at the data, what if we took away all of the green dots and only look at the other ones? Then wouldn't it be almost a linear function? Let's try. And this I can do by creating a new data frame, filtering out start group number 5. And this time I specify the data up here into the smoothing function. So I draw the points exactly like I did before, so all of the points, but I only use points from the groups that are not in 5. And then, as you can see, you pretty much get a linear function. And also you see Bengt that is up there somewhere. So you can only speculate why this is the case. Why do group 5 diverge so much from the rest? You will really need more information to know why this is the case. If I would make a guess, then perhaps it is more than just Bengt that has done Vasaloppet many times before, and perhaps earned their position in this start field after their old merits rather than new ones. But I can only speculate. Okay, so for the rest of the talk, I will present some more of my favorite geometric objects to use. And the first one is the box plot. This one gives you a rough idea of distributions over categorical factors. So typically on the x-axis we have a categorical factor like the age class, and on the y-axis we have a numerical value. Then for each of these categories we have a box like this and some whiskers up and down. The solid line in the middle gives you the median value of points for this category. And the outskirts of the box here gives you the quartiles of data. So the whole box contains the inner 50% of data in that category. And then the whiskers contain the rest of the data. And in case one of the points or more are deemed to be outliers, then they are marked with a dot, like this one here. So what can we see from this visualization? First of all, we see that the youngsters are not doing that well compared to the rest. If we go up in age, we actually get better and better finish time up until start group or age class 40. So people between 40 and 44 years old. So that's interesting and also quite nice because I'm 38, so perhaps my prime time isn't here yet. And also you can see that it takes a while before the performance is decreasing drastically. It's not until age 60 or so that you will perform significantly worse in, well, at least this year's Vasalopp. So, the next object is good old histogram, which gives you a less crude picture of the distribution. So here I plotted the distribution of skiers, their time in Mora. So here I specified the x-coordinates to be in Mora, and in the geom histogram function I set the bin width of 900 seconds. So each of these bars holds 15 minutes of skiers. So the number of skiers within 15 minutes here. And there are a few things that are perhaps unexpected. For example, here is a peak. There's really many skiers that come in just before 10 hours. And once again, you can only speculate why this could be the case. Perhaps I have no idea if they make the tracks better during the race, for example, or if unusually many have a tendency that they want to come in before 10 hours or so. Also, you see a pretty sharp drop off here in the data, and that's because there is a limit to how late you can come to different checkpoints. Okay, so let's say now that we want to show the distribution over every start group. How do we do that? Well, it's pretty difficult to stack histograms because it will be bars on bars on bars on bars. And instead we can use frequency polygons like this one by adding a layer, geom frec poly. And we specify, again in the static mapping, the color to be the start group. Again, bin width of 15 minutes and a line width of 1.5 here. So this shows the exact same thing as the histograms, but I would say it plots the contours of the bars, or what you call it, so line plot instead of bar plot. And then you can see all of the distributions lined up, which I think is quite handy in many times. If you're now a person that really likes your histograms and really wanted to use histograms after all, then okay, there is a way, and that is the facet plot, using that one instead. And by using this, you can add a variable or a visual property through subplots rather than aesthetic mappings. And then you can use the histogram, good old histogram, and instead add a facet wrap over the start group. This will give you subplots for each of the start group, giving you a number of different distributions. And I would say that there are many uses for facet plots, It's a really neat tool in many cases. There are better examples than this one, actually. And if you want, you could add a variable here, and then you will have the start group subplots. Well, you could have a grid of facets. So up here you have one variable, and here you have another variable. Well, it's better if you check that out yourself. So facet grid is also an option to use. Okay, so that is all that I had to say today. Thank you very much for listening, and have a further good evening.